So far, we have focused on linear homogeneous recurrence relations. And so again, these were recurrence relations where they were of this form, but without of f and n here, right? And so now we are considering recurrence relations when it's the same as a linear one, but like the linear homogeneous one, but with an extra term here, f of n, which is a function of n. And so this is called a non-homogeneous because of this additional term here, right? So the recurrence is still linear, but and the coefficients are still constants, but now you have extra stuff. So for example, when we looked at the Tower of Hanoi, we had the following recurrence. And so this is non-homogeneous because of this plus one term, right? And later on we'll see some example of solving also another non-homogeneous one. So let's see what's the basic idea for solving these, right? Okay, so the general solution, so let's say that this is our linear non-homogeneous recurrence relation. Now the general solution of this is going to be of the following form. It's going to be the solution to the homogeneous. So we saw how you solve the homogeneous case. So write out the homogeneous, find the solution to that, and that's going to be this part, plus a solution to the particular case. So you need to find any solution to this, and you're done. So in other words, to solve this here, find any solution, any particular solution, and then add to it the solution to the homogeneous, and this will give you the general form. And so, of course, we saw how to do this. The question is, how do we find particular solutions? Now, there's a certain class of cases for which we have a nice theorem on how to find them. So, if our linear non-homogeneous recurrence has this term f of n, which is of the following form, if f of n is a polynomial of n times some s to the power n, right? So it's just some polynomial multiplied by some number s to the power of n, then we can find its particular solution depending on s here. So there are two cases. If s is not a root of the characteristic equation, then you have a particular solution of this form. And now if s is a root with multiplicity m, it's essentially a solution of this form, but you need to multiply by n to the power of m.